The new Raspberry Pi Zero 2W is a great improvement over the original board. But just how far can we push its performance? Let's find out. Hi and welcome to Bytes and Bits. The new Raspberry Pi Zero 2W already gives a substantial performance boost over the original Raspberry Pi Zero W, but we can squeeze even more processing power out of it using overclocking. So overclocking, it's a technique where we run the processor, the graphics card and the memory at a faster clock rate than on the standard device. So doing this makes all the devices on the board run faster, giving us a performance boost. So to overclock a Raspberry Pi, it's actually very easy. We only have to edit the config.txt file stored in the root folder of the boot partition. Now, if you already understand how to do this, then please check the video description down below for links that let you jump forwards in the video to actually get to the settings that I used. And this has allowed me to get the desktop running at 1.3 GHz and RetroPie running at actually 1.4 GHz. But if you're not familiar with overclocking, I'll now take you through the whole process. Now, the processor on the Raspberry Pi doesn't always run at its full speed. So when the device is not doing very much, for example when you're just sitting looking at the desktop, it turns down the processor speed to save energy. So we need a way, first of all, of seeing how fast the processor is running so that we can tell when our overclocking is actually working. Now we can easily do this by adding a plugin to the taskbar panel. So if you right click on a blank area of the taskbar and then select the Add Panel Items, you'll see the Panel Preferences dialog box open up. Now make sure that the Panel Applets tab is selected and then click the Add button to add a new plugin. Simply scroll down until you find the CPU Freak front end plugin and then click the Add button to put that on the panel. When we overclock a processor, it actually needs more energy to run, and this extra energy gets dissipated as extra heat inside the chips on the board, so they start to get hotter. Now the processor chip has built-in thermal protection, so when it reaches its maximum operating temperature, it will automatically slow the processor down. So we need to monitor this temperature to make sure that we don't hit the thermal limit. If we do this, all of our overclocking settings will simply be turned off. Again, we can add the CPU temperature monitor plugin to our task panel bar. So now that we've added those panel items, you'll see two extra icons in the taskbar. The processor temperature is always on display, but to see the processor speed, we need to hover over the processor icon. And as you can see, at the moment, because the computer isn't doing anything, the processor speed has been turned down to 600 MHz. However, if we start the browser application, we put a processing load on the Raspberry Pi, and it responds by turning the processor speed up to its maximum, which is currently the default 1000 MHz or 1 GHz. Now the whole point of overclocking is to make the Raspberry Pi run our software faster than the default settings. So we obviously need a way of measuring how fast our board is running. We can do this just by eye and just looking to see if our programs are working better, but it's much easier to use benchmarking programs, and these will actually put a number to the speed of our system. So as we adjust our overclocking settings, we'll then be able to see any small changes in the overall performance. To install the benchmarking software, the best way is to open up a terminal window. We need to make sure that the whole system is fully up to date. So first we need to update our database by using the sudo apt-get update command. And once that's finished running, we can then do a full system update using the sudo apt-get full upgrade command. And this will take a while to complete, so just leave it running until you get back to the normal system prompt. So now that the operating system is fully updated, we can install the benchmarking software. The first package we'll install is sysbench. So use sudo apt-get install sysbench. And sysbench lets us run tests which will measure our processor and memory speed. Now, to measure the graphic performance, we'll use the GLX Gear software, which is part of the Mesa utils package. So sudo apt-get install mesa-utils. So as I said, we'll be using sysbench to measure the speed of our processor and memory. So the processor speed is measured by getting it to calculate a number of prime numbers. So if we use this command on screen at the moment, it will calculate the first 10,000 prime numbers using all 4 processing cores and report back to us how long this process took. The less time it takes to complete, the faster the processor is running. And if we change the number of threads to 1, then we'll actually measure the speed of a single core, which again is a useful figure to get hold of. To measure the memory speed, we use this command, and this will continually access 1K blocks of memory until we've accessed a total amount of 2 GB. And again, the performance is measured in how long it takes to complete the task. Our GPU benchmark is run with the following command. And this will open up a window with some rotating gears. And the software basically tries to draw each frame in the animation as fast as possible and report back to us how many frames per second it's managing to complete. The more frames per second we get, the faster our GPU is running. So as I mentioned earlier, to overclock a Raspberry Pi, we simply need to edit its config.txt file. And I find the easiest way to do this is using the terminal. So if we use this command, it will open up the file for our editing. Now if you scroll down, you'll come to a commented out section with one of the basic overclocking parameters. And all we need to do here is to type in our new settings, save the file and reboot the computer. So the settings that I'm typing in now are the default speeds for the Raspberry Pi 02. We'll then start altering them to get the board running faster. Now the settings really work in pairs, and it's best to adjust one pair at a time so you can see what effect your changes have. So we'll start with the main processor core speeds, which is adjusting using the ARM frequency parameter. So the number specified will set the processor clock speed in megahertz. So 1200 will set the clock speed to 1.2 gigahertz. The overvoltage parameter can be used to help with instability as we increase the clock speed. Now, I've explained how all this works in detail in a previous overclocking video, and I'll put a link to that in the description down below. But basically, as we increase the clock speed, the actual shape of the electronic clock signal can cause the processor to crash. And by increasing the processor voltage, we can tighten up this shape, allowing the processor to continue working at these higher speeds. But for now, we'll just change the frequency and see what happens. So to save this file, press the Ctrl X, then yes to save it, and then press Enter to save it with the same file name. We then need to reboot the Raspberry Pi and run the benchmark test to see if we've made any improvements. Now sometimes, or actually quite often, we'll either find that the system won't boot at all, or in this case, it will crash while we're running our tests. And this is actually quite normal, as we're trying to find the best overclocking setting by trial and error. Now, if the system crashes, we need to re-edit that config.txt file to try a new set of values. Now, if your Raspberry Pi is able to boot, you can just edit the config.txt file using that nano program in the terminal. But if you can't get the computer to boot, the easiest way is to simply take the SD card out of the Raspberry Pi and plug it into a normal PC. You'll then find that you have a disk drive named boot, and inside the root of that you'll see the config.txt file, which you can then edit with any sort of text editor such as Notepad or Atom. Now, one of the things to bear in mind is that what's possible with overclocking does rely on individual device properties. So when chips are fabricated, they have slight variations, The quoted speeds for devices are always guaranteed to work, but naturally the absolute maximum speed any one single chip can run at depends on how these random manufacturing variations came together. Now, my Raspberry Pi 02 will be different to yours. You might be able to get more speed, or you might crash with my settings. It's really just down to pot luck. So when it's time to set the overclocking settings, there's usually a process we go through and an order we do them in. So I always start with the processor frequency. I will gradually increase it, and as the system crashes, I'll then gradually increase the overvoltage setting to try and bring it back to a stable state. And eventually you'll get to a state where you've got a processor speed you're happy with and a stability in the system. Once you've got that, we can then start to adjust the core frequency and GPU frequency, and both of these then relate to the actual graphics processor. I start by increasing both together, and eventually I'll hit a limit for the core frequency value, and then I can try increasing the GPU frequency value to try and get slightly more performance out of it. And then once we've got some settings for our GPU, we can go back in and use the GLX Gears benchmark to see if the system is stable and runs any faster. So for our memory speed, we have the RAM frequency and the RAM over voltage. And these work in very much the same way as the processor frequency. So we increase the RAM frequency and then try to pull it back into proper timing using the RAM over voltage. Now, after a bit of playing about, I ended up with the following set of parameters for my Raspberry Pi 02 running the Raspberry Pi OS. Again, I'll put links to my main project page on my main website, which will have all of these settings listed out for you. So as you can see, I managed to get the processor speed up to 1.3 GHz, and overall this gave around a 25% increase in performance, and you can see that from these benchmark scores. Now, my main aim for this increase in performance was to get more processing power for my Raspberry Pi 02 when it was running RetroPie to emulate retro gaming systems. Now, to edit the config.txt file in RetroPie, you can either plug the SD card straight into your main PC and edit it that way, or you can call up the emulation station menu when it's running, select quit, and then exit emulation station. And this will drop you back into the Raspberry Pi terminal. Now, I found that RetroPie, it really does not like you playing with the GPU settings for some reason. So anything above the default setup seems to crash the system after a few minutes of play. So I simply deleted those settings and left them as standard, and then just played with the processor and RAM frequencies. And doing this, I was actually able to get a stable 1.4 GHz for the processor, and that was using these settings listed now. So I did run the benchmarking tests again, and as you can see from these performance figures, it actually did give better performance than the 1.3 GHz processor setting running with the GPU tuning. And that even was on the GPU benchmarks. But unfortunately, although I could get it to run stably for a short time at 1.4 GHz in the Raspberry Pi desktop, it really wasn't stable, and it just simply crashed after a few minutes. So now that we have the system running stably at the overclock settings, the one thing which we do have to look at, which we mentioned earlier, is overheating. So if we run the GPU test in the desktop with the processor set to 1.3 GHz, you can see here that the temperature of the processor does start to get very high. So to combat this, you really need to add some cooling to the processor chip. The simplest way is to buy some stick-on heat sinks, and they simply are little bits of aluminium which will stick to the top of the processor, and they do help quite a lot to keep it cool. You can also buy metal casings which have heat dissipation built into them, or you can add some airflow across your heatsink. And you can see here, all I'm simply doing is blowing with my mouth across the heatsink, and you can see that does drastically reduce the core processor temperature. Now the other thing you'll have to think about in terms of temperature increase is how you take that into account with the way in which you're going to be using this Raspberry Pi and installing it. So I intend to put my Raspberry Pi into a handheld gaming device. So I may not have enough room even for a heatsink, and even if I do, it's going to be in a fairly sealed container without very much moving air, which would take the heat away. So even though I can run my processor at 1.4 GHz, I might not be able to do that and use all of that power safely. So as I did say earlier, my ultimate goal is to improve the performance of retro gaming emulators. So let's have a look at how a 1.4 GHz Raspberry Pi 02 compares to the stock board. Looking at arcade emulation first, in my previous overview video, and I'll put a link to that in the description down below, we saw how the new Raspberry Pi allowed the MAME emulator to run at pretty much full speed. So overclocking is simply going to give our Raspberry Pi some extra performance in reserve, so hopefully it will cope with any game that we throw at it. Hard to emulate games on the Sega Mega Drive ran at fairly close to full speed on the stock Raspberry Pi 02, hitting around about sort of 50 frames per second on some games. But running at 1.4 GHz, we now get a steady 60 frames per second in pretty much every game that I've tried. Vectorman, which is playing on screen at the moment, was dipping down to the mid to low 50s on the stock board, but now again, as you can see, it's running at a constant 60 frames per second. Gunstar Heroes as well actually was dipping below 50 frames per second on the 1 GHz board, but of course the 1.4 GHz speed boost is now keeping it up at that constant 60 frames per second. Now I had hoped that with a bit of tuning, the Raspberry Pi 02 would be able to run some of the less intensive Nintendo 64 games. Super Mario 64 does run a bit better, but it's still not really a playable game. Perhaps with some extra tweaks to the emulator itself, it will run better, but I think we really are at the limits of what this little Raspberry Pi can do. PlayStation Portable or PSP games are going to be very hit and miss. Some of the very low power games will run, but as soon as you start to put a bit more stress on the emulator, the Raspberry Pi isn't going to be able to keep up. Little Big Planet isn't a particularly processor heavy game, and the Raspberry Pi does cope very well with the first level, but as we'll see, as soon as we get more objects onto the screen and having these needed to be modelled, very quickly the Pi runs out of oomph. Original PlayStation emulation was good on the stock Raspberry Pi 02, but again, with this little bit of overclocking, we get very stable full-speed emulation. So all of the games I've tested ran perfectly, and we're running Colony Wars here, which is actually one of the harder ones to emulate, with a lot of 3D animation and things happening on the screen. And as you can see, we are getting pretty much a consistent 60 frames per second all the way through here, no matter what's actually happening within the game itself. So that's really pleasing to see that we are getting very, very good PlayStation 1 emulation with this really small form factor Raspberry Pi 02W. So getting the new Raspberry Pi 02 to run at 1.3 GHz or even up to 1.4 GHz is fairly easy to achieve. You do need to watch that temperature, but it does seem to be very stable at these new clock speeds. Now overall, you're going to get a good 25% performance increase across the board. From a retro gaming point of view, although this doesn't unlock any of the slightly more modern gaming consoles, it does consolidate pretty much everything up to the original PlayStation with smooth, full-speed emulation. Now, I haven't yet tried increasing the resolution inside the emulators. You can run them at higher than native resolution. And again, this is probably somewhere where we could make use of this extra processing power. Now, I hope you found this video useful, and please do click that like button and subscribe to my channel if you want to see any more of my videos. Don't forget to check out my website, and I'll put links to that in the description down below, and there you'll find more information, all of the code and settings used in this video, and many more gaming, coding and making projects. So have fun playing with your new Raspberry Pi Zero 2W, and I look forward to seeing you again very soon. So bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.